Good afternoon. I'm Tim Takaro with the Climate and Weather Group, and I'm joined here with Johannes Feddema and Diane Chaumont. We're going to quickly run through this. I have to say it's very exciting to be in this room with all of you and to already feel the synergies building, because I think we really do have something here. So just in terms of overview, I'm sure most of you know about the links between climate and health. These are some of the more frequently cited ones: cardiopulmonary outcomes, arrhythmias, coronary infarction, congestive heart failure, asthma and COPD. All of these linked through air pollution, airborne pollen and fungi, and particulate pollution from wildfires related to drying forests. Heat and cold-related injury. What's been focused on mostly is the extremes, but a big part of climate change is the increase in variability, and we don't focus as much on the variability in climate, which does seem to have both cardiovascular and direct mortality related effects. Extreme weather injury, this is obvious from flooding events, wildfires, etc. Geographic shifts in infectious disease risk has been shown in many spatial areas around the globe, and then waterborne and foodborne illness. These are all more or less direct climate change effects. And what we have not listed a lot here is some of the indirect effects that might be mediated through food shortages, food security, water shortages, and the like. But in all of these, climate change is a modifying effect. These are all multifactorial diseases. We've talked about many of the exposures related to them. Climate and weather is just one additional modifier. So in terms of future opportunities, there are many of them. We are focusing, I'm glad to hear, on the spatial characteristics, because spatial and temporal characteristics of climate change are a great integrating platform. We've discussed the development of a lifetime climate exposure metric using observational data. We're very pleased to have the connections with residential history cohorts. That's a key component of this. We've come up with the acronym already. This is CLUE, Cumulative Climate Lifetime Urban Exposures, CLUE, as a way of integrating both the lifetime temporal exposure with spatial variation. We believe there is plenty of room for investigating additional health outcomes. Climate scenarios all have opportunities for adaptation embedded in them based upon the vulnerabilities, some of which have been discussed, and I'm looking forward to the neighborhood and communities working group discussion of how to integrate vulnerability into some of our work. And leaving with this question of, does your lifetime climate exposure in an urban environment impact your health? And if so, what are those windows of impact? Clearly, early life development and development of the immune system. We've already heard pollen and air pollution mentioned in that context. But are there other windows of vulnerability in lifetime that particularly make climate relevant? In terms of exposures of interest, many of these have already been mentioned. In fact, perhaps all of them, except the extreme heat events. Does it matter if you have multiple extreme heat events in your lifetime exposure? Whether there are the usual suspects there, but again, I would focus on the extremes and the increase in variation. airborne fungi and pollen, tree and ground cover, all related here. Water budgets, we will get into a little more deeply in a moment, but this is both groundwater and surface. The forest conditions and land use conditions that promote fires is a big interest of us. And then this composite measure, which we have been batting around in our group for our meetings that Johan will get into some detail about, of local climate zones, and if this is an integrated measure that might be used to build the clue that we were talking about. And then we are very interested in the other variables that are created by the groups that you've heard already and that you'll hear later this afternoon. So with that, I will turn it over to Johan to talk to you about the local climate zones.
Thank you. Well, there's no handout, I forgot. So, but we have the slides, so we'll go to those. So the idea of local climate zones was actually developed by Ian Stewart, who's sitting in the back right there, with Tim Oak at UBC. And the idea was that, for them anyway, to think about our urban areas in a way of, we all know about urban heat islands, but the urban heat island, for example, can be very directly linked to urban morphology and sort of where you are in your city. So dense downtown areas, tall building districts, have much higher heat islands, for example, than suburbs, etc. So Ian actually devised this really wonderful sort of local climate zone index, basically, where you can look at the height of buildings, the spacing of buildings, a variety of different metrics about urban morphology, which then are directly linked to, for example, urban heat island characteristics. Now, as it turns out, when you look, just looking at this diagram, so this diagram is sort of a visual representation of 9 different urban local climate zones. Oh, so, yeah. We also have some rural ones, but we won't focus on those. So the idea was that you could use this as a metric. It has greenness in it to some degree, as a summary statistic. It has spatial gaps between the buildings, height to width ratios of the buildings. All this relates to air quality, temperature, almost every variable we've talked about so far. So we were thinking about this in terms of a sort of an index that we could use. And if we could look at how much time in your life you have spent in LCZ 1 versus LCZ 5 versus 8, that might tell us something about your health. So we're thinking about using this concept to track essentially people's climate exposure in a sense. As it turns out, this concept, so here's a summary of some of the statistics that kind of are defined. Notice these are ranges, but basically we can use these classes to identify a variety of different variables. One of the things that would be really interesting to do is to take all this detailed information that some of you have on all of these variables we've heard about and correlate it to this and then see if we can apply this. The other thing is that right now there's a workshop going on in Hong Kong, which I was supposed to be at actually, where we're introducing LCZs for a global application. There's a group called WoodApt. It's international. I think Austria, Ireland, US, Canada, Netherlands, a whole bunch of places, Hong Kong. But basically what we've done is we've actually created a citizen science project where someone can actually map their own city into LCZs using Landsat data. So what you do is you go to Google Earth, you zoom in this case we've zoomed out, but you can zoom in right to the street level and identify in your own city, presumably that you know well, the neighborhoods that you think represent an LCZ1, LCZ2, et cetera, et cetera. You need to have at least 5 of each class that you plan to characterize, and basically then all online, this can all be done by anyone, anywhere in the world. You get a map back that gives you your LCZs for your particular city. So the WoodApp project is actually trying to do this. We have about 100 cities mapped in China. We have about another 200 cities, probably 300 by now, worldwide. The idea would be to do this for as many Canadian cities as we can, and to identify, and essentially for each and every city, identify all the neighborhoods into LCZ areas, right, in a GIS, And then we could use these Elsies, then link this, and by the way, here's Vancouver. I had 8 students map Vancouver that I thought knew something about Vancouver, and this is the average result from all 8. We're testing the sensitivity of the methods. And sorry, there's a difference in the class colors here compared to the last one. But the idea would be that we do this for a number of cities, and once we're able to identify these areas, we can use the Elsies ADS as a summary, essentially, of the climate that people live in, including all of these sort of air pollution metrics, et cetera, ideally. So the idea would be to hopefully then, actually, what we really would like to do is look at people's lifetimes movements. Where did they live? Where do they work? How much time do you spend in each LZZ throughout your life? And then hopefully that would be a correlate to health outcomes. So we're very optimistic that that would be a pretty good metric, but we don't know. So this is all very experimental, brand new. This method has only recently sort of been made available widely. The other thing is that we feel like many people, when they think about climate, the temperature comes to mind, precip, but they all forget about all the other variables. So soil moisture, extreme events, seasonality. Do you live in a climate that's extreme from winter to summer or not, et cetera? How do we identify extreme events? Oftentimes we do this for temperature, for example, in terms of heat exposure, but what about drought? Drought directly affects not only people, but also things like pollen for trees, all these other sort of metrics that, we're talking about. So we're thinking that instead of just using sort of straight temperature and precip data, we would try to develop a water budget scenario with integrative moisture indices, essentially, to identify both wet and dry conditions. So wet can be linked to, for example, funguses and exposure to things like that. But at the same time, we could also do that for drought and look at trees, for example, and other kinds of correlates. The other thing we'd like to do is use a water budget, and so we have actually a 10-kilometer resolution data for all of Canada, weather data. This is from PICS at UVic. And we see on your left, present conditions, and then a scenario for the future based on IPCC projections. Again, it's very critical that these projections really have to come out of climate data, and then we have to link that climate data to other variables if we want to do projections into the future. So I think there's that step that needs to go, and how do you create projections into the future? So often you have to work through climate data, but then moisture indices, for example, have higher correlations to vegetation impacts and other such things than just temperature and precip alone. So we also have the same for precipitation. The other thing to think about is that seasonally these things may be quite different. So we expect, for example, a drying in summer for many areas, wetter winters, but warmer conditions greater in the winter rather than the summer. So the signals in the future are going to be quite different, and we come back to variability between winter and summer, and sort of an annual exposure to extremes, as opposed to just the kind of thinking about extremes as usual. So the goal is to sort of develop these kind of metrics, and then hopefully present them to you over the web.
Okay, thanks. So, hi everyone. I'm Diane Chaumont from Johannes. What we can offer to CANUE is mostly a platform, a software platform in which we could deliver you the climate data. So during the starting part of the CANUE project, I think the thing we have to do is to identify your needs, to get the data in a software platform that you could reach, that you could consult in the web. And we should also look at which impact models we could link to this platform that would use the climate data. Impacts model could be like models evaluating the impact of heat waves on health, but also on biodiversity, tree species, and things like this. So I'm talking about the PAVIX project here. That's a project that we have, for which we got funding at Johannes for 2 years. I was happy to see that you had the fact sheet in your package regarding the PAVIX project, so you can find more information regarding that. But the project is covers all Canada. PKK is involved. Environment Canada is involved too. So we are trying to share all the tools that could be used or to put together to reach climate data more efficiently. So the other thing we would like to provide in this platform or to develop in the weather and climate team is a weather urban model for 5 cities in Canada. We already have links with Environment Canada and the UQAM University, and they developed this kind of model. That's a kind of model where you can do an impact to climate change study, but also you can test adaptation measures. What could you change in the city infrastructure, in the city greenness, to get a better quality and be adapted to climate change? The concept like local climate zone would be very useful in this kind of model. And so we hope that we could deliver a model, a weather urban model in which you could test the impact of climate change. And we would like in a more longer term to simplify the urban models to offer the possibility to test adaptation measures that could be done on the web and add the impact of climate change in this model. So what we have now, the grants that are already obtained that could overlap with CANUE is the financing from CANUE for the PAVIC platforms. You already talked about the WUDAT project. And who could say a few things regarding the barriers?
Yeah, I can just mention the recently funded Environmental Community Health Observatory, which is focusing on resource extraction across Canada, and including the north. In regards to the barriers, this safe space for amalgamating data, safe in the sense of enough behind the firewalls that our research ethic boards are happy, but accessible at the same time. And I think this is kind of the devil is in the details problem, but it is very clear in my experience working both in Canada and the United States that the organizational barriers are still present, even in settings where the investigators are quite willing to share data, but something in their bureaucracy prevents them from doing that. So that's what I mean by the safe space and enabling the integration of all of the things that we've talked about so far this afternoon in a platform that enables integration. So I don't know if we have anything else. So yes, the future grants. Did you want to talk about CANUE?
Yes, so we will again go to the CANUE funding to ask for new fundings for 2 years, in which we could reuse the platform that we are developing now. So we are interested in adding health application, like adding a new, the platform looks like you have an access to climate data and you can add services on it. So that could be service regarding what is the impact of climate change on the biodiversity. So we are interested to find partners who would like to add a service regarding the impact on health. We're working with the Centre de Recherche en Informatique de Montréal to submit this proposal. So this makes sure that we are like at the state of the art regarding software development. We are also thinking of adding the seasonal forecast from Environment Canada, if that can be useful to make some management regarding health again. And the other point is the airborne pollen. I don't know who had at this point. That's you.
So this airborne pollen and fungi study is a Health Canada hopefully funded. It was just submitted for the Canadian Healthy Infant Longitudinal Development Birth Cohort and integrating fungi and pollen levels during the birth year with outcomes for asthma and allergy. It's part of a larger look, including a land use regression model to be built in Toronto and validated with airborne measurements, as well as a survey across Canada of pollen levels over the past 10 years. Future opportunities are for discussion. We're really open to have any of you join us tomorrow for our group at 8 o'clock, and certainly open to any discussion right now. I think we have some time. Did you want to mention something else? Did you want to mention something else? No.
So it seems that the Oranos platform, it's something that can help us visualize the climate data and multiple layers of data.
Yes.
And then there was some talk about incorporating health data on top of that, and then being able to look at different scenarios. I'm wondering, are the connections between changes in the exposure and then subsequent changes in the health outcome, is that something that others are going to have to program within that GIS software in order to see the impact, or is that something that's built in some way already?
The first step, like we started the project last May, so it's quite new. The first step was to organize the climate data, spatially and temporally, and transform them in GIS format to permit the superposition of data. But we are doing like maybe 3 pilot projects. One regards the water sector, and I don't remember the others. So the way we think that is we have built the platform regarding climate data, then we can add services like health. I think that's exactly what you said. So we will continue to develop the platform like this by adding, so that's what we call services, but that could be in the health sector or other things. So, and no matter if the impact models is really built on the platform or if it is connected with the platform in another way. I'm not a software specialist, but I think we have a lot of flexibility there.
This raises a larger question, I think, about the relationship between CANUE and the exposure platform and all of the different cohorts that have health information. And Paul, you alluded to this in your introduction. I think you called it a pre-study. The notion of how the exposure data meets the health data, I think, is something I'm very interested to hear more about, because the way it's been explained to me so far is, yes, we produce the exposure platform, and this is taking a form of a GIS, but the investigators within the individual cohorts then apply it to their cohorts. And that, if that's the model, then there is kind of a disconnect. So, Jeff, you're shaking your head. Maybe you can elaborate on how that relationship is going to work between the exposures and the outcomes.
I'm going to use my executive privilege to hold that question, because we'll definitely be talking a lot about that, but maybe, Mike, if you have something specific to this particular project,
so
we'll get there.
I guess it's sort of something that I wondered that if you thought about it, and maybe an opportunity for kind of synergies across some of these working groups. So there's been some interesting work coming out on, actually not that new, but on cold effects. Sorry. So there's been some work on cold effects of noise, and so much of what I heard was sort of focused on future warming, urban heat island. So cold effects and thinking about that, but also thinking about the indoor environment. So for example, air pollution, we're trying to do these infiltration models, which talk about tightness of the building, let's say leakage, which could also be useful for looking at the effects of outdoor temperatures on indoor. And it just seems like there's an opportunity to actually think about it and sort of get this where we could actually look at both those factors at the same time. So.
Yeah, I think it's really important. I mean, the exposure moment was brought up earlier today, and what's happening indoors is where people spend 80 to 90% of their time. So it's a really critical component of getting your clue.
Just say one thing. So it's actually interesting. We just recently linked the Elsies concept to WRF, which is a weather forecasting model. So we've actually tried to simulate, and we're actually trying to do this in a global climate model, to NCAR's model, but is to sort of look at indoor. So one of the things was on their citizen science. We'd like to use phones, for example, to get ideas about what's your thermostat set to, because we have no idea globally what people do. Like, it's culturally determined, all kinds of things. Similarly, what's your building made out of? Do you have brick buildings or do you have wood buildings? It makes a huge difference in terms of heat island impact. So we're actually using models to simulate those sorts of things right now. I'm not sure we can answer your question directly, but indirectly, I think we can think about sensitivity tests in sort of urban canopy model types of settings.
We have one short question now from, oh, you got it? I'm sorry, I thought it was Bert. You got the last word, Mike.
I just wondered to what extent you're going to be looking at adaptation capacity, so air conditioning, community resilience to extreme events, other types of initiatives to minimize the impacts, whether it's planting green space. It seems like that, I mean, it's incredibly complicated to predict the heat islands, but the adaptation is just as complicated and probably equally important.
Yeah. So there are different ways to do that one too, I guess. Again, I think personally, I've been working on simulating these things. So, what if we gave the entire world air conditioning, right? What does that do to our entire carbon emissions? Or those kinds of questions. But in terms of health outcomes, I think we can't forget about the indoor piece. Like, how much time do you spend indoors, right, as opposed to outdoors? So I think we can't answer all of those things, but I think as we learn more about how people behave, perhaps, in different kinds of neighborhoods, in different places, in different external temperature or climate conditions, can we link those? So what would be ideal is if you knew someone's lifetime LCZ exposure, but at the same time also knew what the background climate was in terms of sort of average climate conditions, how many events, dry, wet, whatever they've been exposed to that are extreme, like in the top 2% or something, and then add to that socioeconomic status, not only their own, but for each of those areas, because once we have these LCZs and we have the city maps, we can overlay that with socioeconomic information. And so you can create multiple LCZ1s that relate to these different classes. Or you can just autocorrelate them, or sort of look at them. But so I think there are lots of opportunities here. The question is building that first bit, right? And to be honest, this is a bit of a dream in the sense that we don't have all this stuff. It's all brand new pretty much. So we would be developing this as a first if we can get there. So one of the things we didn't list is I plan to have some proposals to try and get this off the ground. But I just barely moved across the border, so I'm still doing my immigration paperwork. Get that done first.